Hello, in this lab we'll be troubleshooting Kubernetes cluster component failure. But before that, first we will discuss Kubernetes architecture. But why? So this is required as this lab required understanding of different component and their uses in Kubernetes cluster. So for that, first we will be discussing Kubernetes architecture. So we know that we have our application that consists of code, configuration, dependency, and other things, and we require to run this application. So first we will build this application, and this will create a Docker or container image of this application, and then when we run this Docker image, we will get container. So now these Kubernetes nodes host this container, means these containers will be run on Kubernetes node. Now we can take example as Amazon EC2 instance can act as a node. So we can run container on EC2 instances. So that will provide the environment and other things that is required by this container to run. Now the thing to note that these containers are not directly sent to the node. These containers are packed in a pod and then they are sent to the nodes. But why they are packed in the nodes? Because some containers, this application container can require some environment to run in the node runtime environment. What type of environment? We can say that our application code is written in a Python file. So it will require Python image, that is Python environment, to run into that runtime environment. So that will be provided by the Python image or Python container, the container of the Python image. When we run the Python image, then we get the Python container. So that will also be sent along with this container, because if this Python container is present in some other node and our application container is present in this node, so how our application will run, because that will compulsory require this environment. So this will send along with our application environment and packed in a pod. Then this pod is sent to the node. That's why they are not directly sent. Now this set of container reach the node, and they are packed in a pod that we have seen. Now there should be somebody that manage these nodes, that who are coming and plan these nodes, that who will be running and scheduling. This all task is done by the master node. Now for that purpose, our master node has etcd, scheduler, controller, and API server. Now, etcd store key value pair. That is, it stored which node is present in which container goes to which node. That is, first container goes to first node or second node or third node, and it's also stored the state of the cluster. Means state of the cluster means which pods are present in which nodes, and if everything means where the everything is stored, all the state of the cluster is stored in the etcd. Now scheduler puts container to the proper nodes, means take account into the resources, means this much resources is required for this container to run, so it will allocate that node according to the environment. And the controller ensure proper state of the cluster component, means if desired state is 3, so if current is 2, then it will bring one node. Means key, if the required state to run a cluster component is less than the actual state allocated to that, then it will allocate one more state. So it will take into account the proper functioning of our Kubernetes cluster. Now are these states will interact to the master nodes, means this worker nodes will interact to the master node via API server, and we also set our commands, and we also do our command functioning via API server. That is how many nodes or states we want to run. These all things are provided by us to the master node via API server. Now to run nodes, runtime environment is provided by the nodes, which is, we can see that there are various kinds of runtime environment provided. Example, Docker type of runtime environment is provided. Now we have seen that these worker nodes communicate to the master node via REST API server, so that all the information reaches to the master node. So if something is wrong, then it will respond to the controller manager, and it will then schedule some nodes or something to the worker nodes. But how will this information go to the REST API server? So for that purpose, kubelet is present. So it communicates with the master node using the kubelet, which is present in the all the worker nodes. So status of all the nodes and all the things will be communicated to the REST API server using the kubelet. And node to node communication is achieved via the help of kube proxy. Means if in one node a database is present and in other node application is present, so this application wants to communicate with data present in the other node. So that thing can be done using the kube proxy. So network communication inside or outside the cluster means this is one cluster. So there is some other cluster also that. So then this communication between the nodes took place with the help of kube proxy. So we get an understanding of the Kubernetes architecture, and we see that what are controllers which control all the activities and check if everything is running fine. There are different type of controller. We can see that first running stateless application there is deployment controller, and for agents like monitoring and logging which must be run on every node so that we can monitor and log the events that are occurring in every node. So for that Daemonsets type of container Daemon type of controller is used, which guarantee that you run every instance on every node. So there are different other type of controller also. So we get an upper level overview of Kubernetes architecture. That is, we provide our commands or kubectl commands. That is, we want to change something and set that we need this much nodes to run this application. These things we provide to REST API server, and this master node there is REST API server present, is the etcd present for storing the state of the cluster. Controller manager is present, scheduler is present to assign proper nodes to the our container so that take into account the resources that is needed for that container, and controller manager configure if everything is running fine, and kubelet is used in every node to communicate to the REST API server, and kube proxy for the internode or outside the node communication. So we have get an overview of what this Kubernetes architecture is. So in the first part of lab, we list all the daemon set that are present in the system. Daemon set, we learned that it guaranteed that one instance must be present on every node. So we list all the daemon set and came to know that kube proxy has been configured as a daemon set. Now kube proxy has been configured as a daemon set, then they deleted the kube proxy. So they deleted this kube proxy. So the desired daemon set is 3. The desired nodes must be 3, but only 2 will be present. But only 2 will be present as one will has been deleted by us. So it will reconfigure itself after 30 seconds, which we will see in the lab. So means when we delete this kube proxy, it will show that the desired is 3 and the current state is 2, but it will reconfigure as Daemon set guarantee that you run one instance on every node. So it will communicate via the kubelet to the API server and reconfigure this kube proxy node, and this will be automatically configured and generated within 30 seconds. In the next part, we get access to the master node and try to change the REST API server image, means image of the REST API server. But when we try to do that, it will not work. That is, only the name of the image is changed, but not the ID of the image is not ID of the image is not changed. So why does this happen? When we get access to the master node, why the REST API image is not changed? So that this is because the pod returned by the kubectl command, that is when we run kubectl command and try to change the REST API server, is a mirror pod. It is not the actual pod returned by the API server. So actual pod is not returned, and these all master node cluster component means REST API server, etcd, control manager, scheduler, these all run on static pods. Now what is static pod we will see in detail, but for an overview, static pods are fully managed by the kubelet. That is, we can see that here the pods are many all these pods that are present in the nodes are managed by the master nodes, because everything is communicated by the kubelet to the master node. But here all the pods that are all the cluster components present in the master nodes are run on the static pod, which are managed by the kubelet. We have to provide a YAML file to the kubelet, and it will manage all the components present in the master nodes. Means API server is not going to manage anything, kubelet is going to manage. So when we try to change through the kubectl command via the API server, it will not change, because kube API server is not managed by the uh, kube API server is not managed by the API server, it is managed by the kubelet, which is not under any control. Then in the third part, we view the content of the etcd specification and get to know that the etcd is responsible for the backing and storing a cluster, that we can see from here. And we also get to know that etcd run on the host network with a port mentioning to listen and to communicate with the host network. And we also retrieve a key from the etcd point and get certificate along with that for our authentication. Means this etcd, we have seen that it is used for the storing the state of the cluster. So for communication purposes, it uses a port which is hosted on the host network, and not use the network to network interaction for the security purposes. So we verified that the etcd is running on that port and verify its endpoint, and also retrieve a key and get a certificate along with that, which proves that etcd is true, and there is nothing security measure we have to take in that. And at last step, we get condition of all the Kubernetes cluster master node components, that is etcd, scheduler, controller, manager. Means we get condition of all these component, but we don't get the condition of REST API server. Why? Because we run the kubectl command to get the condition through the REST API server. So if REST API server is not working, then we doesn't able to run the command. As this is not working, then the command will not work and doesn't show anything. So we only get information regarding these three things: etcd, control manager, and scheduler. So this is how we troubleshoot our Kubernetes cluster component. So we can see from here that first we get info of the kubelet, container runtime, kube proxy, and all these things, and what are these things. Then we list all the daemon set present in the kube system and get the daemon set of the kube proxy. So we get to know that kube proxy has been configured as daemon set. Means if we delete kube proxy, the count will decrease to 2. Here we can see that the count here is decreased to 2, ready is 2, but desired is 3. But it will be reconfigured after 30 seconds when we again run this command kubectl get daemon-set system configuration. Then we get to know that after 30 seconds it is reconfigured, and this ready state uh, goes to the 3 as desired, because has been configured as a daemon set. Next we connect to the master nodes and attempt to change the image of the kube api server that we have seen. So if this would change, this would be have a drastic effect, because we will not be able to run the kubectl commands, because as we have seen in the architecture that we interact with the master node using the API server. So if this API server image is changed, we are not able to run the kubectl command. But we get to know that the image has not been changed, only the image name has been changed, but the image ID has remained the same. So if image ID has been remained the same, the image provided to the us via the kubectl command is a mirror pod. Mirror pod means mirror pod is returned by the kubectl command, not the actual pod. Because these are static pods. Means static pods, these are directly managed by the kubelet and not by the API server, which we can see here. Worker pods are managed by the API server, and all the things are communicated by the kubelet. But these pods, static pods, are managed by the API server, and this is one of the application of the static pods that we have used in the master node configuration, that all these components are configured as the static nodes. Then we go to the static pod part directly and get to know that all these things etcd, kube api server, kube controller manager, kube scheduler, all these are configured as a static pods. Means all the master node components, cluster component are configured as a static nodes, and all the YAML file is provided by them, so that kubelet can run see this YAML file and automatically manage and configure these nodes, and doesn't need the help of the uh, API server for this purpose. Then we get the specifications of the etcd pod specification and get to know that it is used for backup and storing a cluster. Why? Because it stored the state of the cluster. So we can store one state of a cluster and decide how many etcd nodes we need, so that we can communicate with the etcd node and get one state which we want. For the backup purpose and restoring purpose, this is used etcd node. And we get to know that etcd is listening on this port, and these are the certificate used by the etcd port. Then we display the port that are that the etcd is listening to, and run this following command to know that our host is also listening in this port. Here we have to mention here that etcd is installed on the host to interact with the etcd. means to retrieve any data or to get any backup, means to communicate with the etcd. There is etcd installed on the host to interact with it, and we not rely on container within container network for the security purposes. So now we come to the tcp ports, which is listening to which we have seen, and then we run the etcdl command to retrieve a value, which we can see here that this command simply get the value named and along with the certificate, so that we can verify for the client authentication, that we can verify that this message has come from the etcd. Then we disconnect from this. Then for the one more security purposes, we enter this command to get the condition of the control plane component. So we get the condition of all the component, that is we can see, which is etcd, scheduler, controller manager. But we don't get the configuration of the REST API server because we have run the kubectl command. So if kubectl command is running, this means API server is active. If kubectl command doesn't work, this means we get to know that there is problem in the kubectl command, that is there is problem in the kube-api server. So kube-api server is okay, and we get the condition of all the other three components, that is kube proxy, controller and scheduler. So this command quickly tell us issue. Here we can also see that the api server is not listed, since kubectl command would not function if the api server was not handling. Then we also get to know that by the help of this command, kubectl cluster info help, we can, it is useful if we want to know the address of the control plane, means key, means this master node. If we want to know the address of this master node, or we want to dump resource specification logs, we want the all this content in the concatenation format, means we get all these content, resource specification logs and other information in one format. Then we can also use the dump commands to get that. So we have learn how to troubleshoot Kubernetes component and learn about Daemonsets, in which we learn about the kube proxy and deleted that, and then learn about the static ports, which are means master node component. All these are static ports which are entirely managed by the kubelet. And then we get to know that how to run commands in container, and we managed etcd, and get to know about the etcdl, which is installed on the host network to communicate with the etcd. So that's all for this lab, and thank you.